virtual meeting that's going to take place over 3 days, Monday, Tuesday, Wednesday. We are going to be convening in Indonesia next year in September 2021. And that's a conference that's been postponed because of coronavirus. And that's the main reason why we're doing this virtual conference. But the virtual conference itself is a great experience for us. And we've certainly welcomed feedback from everybody about what works and maybe what can be improved. This is a brave new world for all of us. Our 6 conference themes over the next 3 days. We've done theme 1. In a moment, we'll introduce the second theme on human-induced natural hazards. We've got sessions on megacities, on remote observation, on multi-hazards, and on communications and warning systems over the next few days. One thing just to flag up, the chat function in Zoom, the default option will send your chat messages to the panelists. If you select panelists and attendees, you can chat amongst yourselves in the audience. So for example, you might have a discussion point that you'd like to make, that you'd like to put out to all of the audience, and people will respond to that. We cannot manage to keep our eyes on everything that's going on in the chat room. So we will mainly focus on questions that are submitted using the Q&A function. When you submit your question, you'll only be able to see your own question on that screen. I think, as our first session has indicated, it's going to be impossible to answer everything that's asked. But I think what we'd like to do after this event is we'll produce some summaries of discussion, and you will be able to see the recordings as well. Okay, so without further ado, let's move on to our second theme for today: human-induced natural hazards and technological hazards and disasters. I'd like to hand over at this point to Kyle Bradley, who's also in Singapore, and he will introduce the panelists. Okay, Kyle, good morning from UK.
Thanks, David. Let me share my screen. I have the same intro slide, I think. Okay, welcome to the second session of the day. Today, we're going to adopt, for the second session, a slightly different model for how we're going to run it. Let me just give you a little brief overview. First, we'll introduce our panel, and then we're going to start some real audience interaction, because I think, as people have already said, one of the main things about these kinds of conferences that's really exciting is the ability to meet people and talk to people about what we do. And you know, with COVID being present, we can't do that this year. There's an opportunity, though, that this year we can involve more people who maybe couldn't get on a plane and go to Yogyakarta. So we're going to do some live polling to start the conversation and get people's perspectives on the topic of human influences on natural hazards and on the impacts of those hazards. Then we'll do 2 lightning talks, focusing on the human influences on the hazard processes themselves and also on the impacts. And then we're going to end with a Padlet virtual wall. And so people who have been posting their points to the Q&A or to the chat, hold those for now. And when we get to the virtual wall, you'll be able to start conversations and continue to have a conversation even after the panel session ends. We'll have our panelists commenting at that point on the points that you're bringing up. Right now, the chat is open, so you can say hi. But when we start the polling and we put links in the chat, we're going to disable the chat for comments at that point so that the links stay present. So let's move on with our introductions. If I could have our panelists please turn on their cameras all at once so we can all be here present. This includes Susanna, Bruce, and Agung. Okay, we have Agung. And I can hear you, yes?
Okay. Oops. Okay.
Is Susanna here?
Yes, I'm here.
Okay, can you turn on your video? Okay, and Bruce, can you also turn on your video? Yes, you're.
Yes, Bruce.
Okay, we're going to give really brief introductions. My name is Kyle Bradley. I'm a PI at the Earth Observatory of Singapore, and I also work at the Asian School of the Environment at NTU. I work on active tectonics of Southeast Asia and the various hazards that arise from that very dynamic environment, and I'm going to be the moderator of the panel today. Pak Agung, can you please introduce yourself?
Okay, thank you, Kyle. So I'm Agung Haryoko from the University of Gadjah Mada, Indonesia. I'm working for the Department of Geology, and my interest in volcanology, so it's related with the volcanic hazard. Thank you.
Thank you. Okay, Susanna, could you please introduce yourself?
Yep, so the same as Kyle, I'm a PI at the Earth Observatory of Singapore and faculty in the Asian School of the Environment of NTU. I'm a volcanologist. I use statistics, numerical modeling, and fieldwork to look at each of the components of risk, so hazard, exposure, and vulnerability, with the aim of reducing disaster risk.
Okay, finally, Bruce, could you please introduce yourself?
Thank you. So my name is Bruce Malamud. I'm a professor from King's College London. I do statistical and conceptual modeling of a variety of hazards, which you will hear about later. So back to you, Kyle.
All right, thank you. So first, so that we're all on the same page, because this is a pretty complex topic, going from human influences through hazards, exposure, risk, and impact. So we're going to have Bruce give a quick summary of the overall topic to frame the discussion. So if you could share your screen, Bruce.
Thank you very much. So this is a very brief, just sort of overview of what we'll be talking about today. And our session guiding question is, how can one systematically assess the influence of humans on natural hazards and hazard impacts? And so what I want to start off with is one common representation of risk here. And so we have the hazard, the potential magnitude of the hazard, and this includes the probability of a given size event occurring in a defined period or a time in a given region. And we know this. We have exposure, and this is where the people are, the infrastructure, the housing, the production, and we have the vulnerability. And these are the conditions determined by the physical, social, economic, and environmental factors or processes. And the combination of all of these gives us the disaster risk or impact. And so if we now think about the hazard here, the human activities can influence the likelihood and intensity of natural hazards. So if we take an example, I took this picture back in December in the Nilgiris of India, and we see here a bunch of houses, there's roads here, there are drainage networks or lack of drainage networks, and we have a landslide. And all of these human influences can increase the likelihood and intensity of landslides. So hazard is one key component of the impact. Now, if we go to exposure here and vulnerability, the human activities can influence the exposure. So for instance, where the buildings are located, the vulnerability, the characteristics of the buildings. And an example here is an earthquake's impact. And so here we have Port-au-Prince in 2010 in a region is strongly influenced by the exposure and the vulnerability of houses in that region. And so we have all three of these, the hazard, the exposure, and the vulnerability are impacting the disaster risk or impact. And so what we see is human activities can influence all of these, and these in turn influence a hazard's impact. It's complex in time. The hazard here can be single hazards, or it can be multi-hazard cascades or coincident hazards, which will be a theme that will be coming out in later in this conference. The exposure and vulnerability change in time, both as a result of the human activities and the hazard. And so, for instance, here you have pre-disaster vulnerability, then you have a hazard event, say an earthquake come along, and then maybe that earthquake triggers a bunch of landslides, and after the earthquake, the vulnerability has changed. And so when the landslides come along, they're seeing a very different vulnerability or exposure. So we come back to this theme of this session, which is how can we now systematically assess the influence of humans on natural hazards and hazard impact? So I'm going to turn back to Kyle here.
Okay, thanks, Bruce. I'm going to reshare my screen and advance the slide. Okay, so the activity that we have right now is we're going to do some word cloud polling using Mentimeter. So what you need to do, as everybody in the audience needs to do, is on your browser or preferably on a phone, go to menti.com and enter this code, 492750, and then the number 4. And we're going to do 3 polls in a row. And the idea is we're going to learn more about where we're from, what hazards affect us, and what processes that people do, human activities, affect those hazards. So I'm going to open the first poll, and we'll be able to see the live results come in. If you could enter the country that you're joining the session from now. And we will do this for 45 seconds, and we will see how many countries we can get into a word cloud in 45 seconds. So it looks like right now, somehow Singapore, tiny country, is a pretty big word, but the Philippines is edging us out. I can see Indonesia getting bigger. I assume we have a lot of attendees from Indonesia. Let's see, we have a European contingent. I see Scotland, the Netherlands, Italy, France, the UK. I see Spain, Georgia, Taiwan, Nepal. This is a tremendously diverse group of people here. And hopefully when we are able to have the actual AOGS-EGU joint natural hazards meeting in the future, we can all meet. Okay, we have 109 responses. So with that, I'm going to close this poll and we're going to move to the next word cloud. These word clouds will be posted to the Padlet virtual wall, and you'll be able to revisit this at the end of the session. All right, let's move on. So now what I want everybody to do is for your country, where you're from, or where you're joining from, what natural hazards are the most influenced by human activities? So on Mentimeter, you can list 5 and submit them. And I got somebody who was left over from the previous thing. Okay. We're starting to see different natural hazards influenced by people.
Yeah.
Yes.
Yeah.
So Agam, can you please comment on what you see?
Okay. Yeah. So it seems that flood is getting bigger, landslide. Yeah, flood or flooding, landslide still dominant. So many. Yeah. Pull. Okay. Yeah. Still landslide, flooding. So it seems related with the meteorological.
There's going to be a big impact from water.
Yeah, yes, from water. Yeah.
30 more seconds if somebody who really wants fire or haze to ascend.
Yeah, it seems drought also, landslide, forest fire, cyclone.
Ooh, saltwater intrusion.
Earthquake, as small. Volcanic eruption also. Yeah, there is a volcanic eruption.
Okay.
Yeah, earthquake. Yeah.
I think we've made a pretty big list right now.
Yep.
I did see COVID in there, which is, I think, relevant. Let's move on to the final word cloud poll that we're going to do today. In your country, what are the human activities that most influence various natural hazards and their impacts? We'll run this one again for 1.5 minutes.
Okay, so littering, that's an interesting one. Land use practice, for sure. Agriculture, slope cutting is going to be very important for landslides, of course. Housing, yep, so how buildings can affect the impacts. Excuse my cat. Urbanization, yeah, big impact on exposure and therefore impacts. Industry, improper waste disposal. Sedimentation in the river, so I can see that carrying downstream. Water extraction, yeah, that's a big problem in Indonesia, we've seen, for example, with ground deformation, subsidence. We have flood again, pollution, yep. We have a big problem with haze in Singapore, of course, which is from fires. Oh, it's getting so small because there's so many different answers that I can hardly see. Mining, yeah, so we can see the impact from mining. Yeah, there's a lot of different answers in here actually, which is really interesting because we have a word cloud that I can barely read, basically.
Okay, I think when the word cloud loses its utility, it's time to move on. Thank you everybody for your contributions. These will be available on the Padlet at the end of the session for further discussion. Okay, we will advance on. Okay, so I think that as we expected, we see that there are a lot of different human activities. And there are a lot of different hazard processes that those activities affect, and that there are probably highly variable by region, as our panelists commented. So I have two questions for our presenters. First, how can we systematically understand or assess the influence of humans and human activities on natural hazard processes? And Bruce is going to give a short talk on that topic. And second, how can we systematically assess the influence of humans on the natural hazard impacts? What tools do we need, or what thought processes do we need to go through to do that? So I'm going to open the screen for Bruce to please present his talk.
Thank you, Kaya. So I'm just going to do that. Okay, so the lightning talk that I'm going to be doing today is addressing how can one systematically assess the influence of humans on natural hazard processes. And this is work that is done by myself and actually led by Joel Gill of the British Geological Survey, who will be speaking later in the conference. There is a paper related to this very quick 5-minute presentation, and we have put it on a Padlet, which you will later have access to. So the outline here is I'm first going to define some key terms. Then I'm going to talk about a methodology which we use, which is a systematic review for how can one systematically assess the influence of humans on natural hazard processes. We'll then develop a systematic classification of anthropogenic process types, and finally evaluate systematically which anthropogenic process types trigger which natural hazards. So first of all, key terms, natural hazards, a natural process or phenomena that may have negative impacts on society, anthropogenic process, which is what we will focus on here, intentional human activities that are non-malicious but that may have negative impacts on society, and we won't address here technological hazards or disasters. So the second part is doing a systematic review. And so this is a critical review of a broad range of peer and gray literature. We use protocols, we answer specific questions, we use over 120 references, we appraise the quality of the research, we synthesize the research findings, and we aim to be objective over it. So the third part is developing a systematic classification of anthropogenic process types. So with the literature review, which was led by the research of Joel Gill, we identified subsurface processes here. And so this includes subsurface processes such as groundwater abstraction, oil, gas, subsurface infrastructure, subsurface mining, material fluid induction. For each one of these, we came up with a description based on the literature. We did the same thing for surface processes here, and land use change, surface material extraction, surface material addition. And finally, we did subsurface and surface processes, where we did hydrological change, explosions, and combustions. And so what we were left with was 18 anthropogenic processes, which we looked at in detail, and we compared these to 21 different natural hazard types. And you can divide natural hazards into many different types, but this is the classification that we did. Now, finally, what we did is we created a matrix, And the potential number of linkages for every anthropogenic process and every natural hazard is 378 here. And what Joel did is he looked at every pairing of an anthropogenic process to see if that might trigger a given natural hazard. And what we so an example here is groundwater abstraction might trigger earthquakes, or another example would be oil and gas extraction might trigger regional subsidence. And finally, we came up with a grid where we identified the potential of a interaction occurring based on the literature. So we found 57 anthropogenic processes where they might trigger natural hazards. So my very last slide, we presented one method here, 57 anthropogenic process natural hazard linkages identified. The anthropogenic processes triggering the highest number of natural hazards were vegetation removal, nuclear explosion, chemical explosion. Natural hazards with the highest number of different anthropogenic processes are landslides, earthquakes, and ground collapse. And finally, we also reviewed anthropogenic process links where they might trigger other anthropogenic processes. So I will end there and turn over back to the moderator.
Okay, thanks, Bruce, for that interesting presentation. Let me share my screen back to mine. Okay, so now let's move on to the second lightning talk, which is, given a guiding question, how can one systematically assess the influence of humans on natural hazard impacts? And it will be presented by Susanna Jenkins, who's across the hall from me today. So go ahead, Susanna.
Still mute.
And Susanna, you're muted right now. Yeah.
Unmute. There we go. Sorry. And here we go. Okay. So building on Bruce's talk, I wanted to look at the other two components of risk, so exposure and vulnerability, and how humans can influence those in order to change the impacts of natural hazard. And I wanted to frame this within a wider systematic approach that we've taken, which is looking at all potential parameters that can change the eventual impact. And the paper for that is currently in press with Frontiers, so the link is here, and this was by my colleague Yolanda Lin and others. Okay, so I wanted to frame this within the problem, which is also a solution, which is the past is the key to the future. And we use this phrase a lot in geoscience. And it's true, we have the past to rely on. In order to forecast any disaster risk, we have to rely on catalogues of past events. However, there are a few limitations with that. One is that records can be short, they can be just a few hundred years or less, and they're often limited in terms of the quality and quantity associated with them. Exposure and vulnerability, of course, are dynamic. Cities can grow within 200 years, so the impacts from an event 200 years ago will not be the same then as they are tomorrow, for example. And what I'll focus on with this lightning talk is this last point, which is when we look at events in the past, they are actually just one realization of a suite of potential outcomes that could have occurred with tiny little tweaks in the hazard, exposure, or vulnerability parameters. And that's called counterfactual thought. So we developed a framework which is trying to look at how we might develop a full suite of past events. So not just what happened, but what could have happened, so that we have a broader database from which to draw from for forecasting future disaster risk. And we saw some key parameters that could be changed in order to change the eventual impact. And I wanted to talk about the exposure and vulnerability size. So for example, an energy release would be a change in the hazard, and a change in the time or location could be something that Bruce was talking about with how hazards are influenced by humans. But specifically on the how humans affect exposure and vulnerability, I wanted to give an example. This is a volcano in the Caribbean, Montpellier. It's about 8 kilometers in that direction. And in 1902, there was a current of hot ash and gas and rocks that basically came down into the city of Saint-Pierre and annihilated it and killed about 28,000 people. Now, this is interesting because had it happened 3 days later, there would have been an election that had happened, and the governor was deliberately trying to keep people in Saint-Pierre there because he knew they were favorable to him and his policies. And so even though there was knowledge that this eruption was going to happen, people were not evacuated when they perhaps should have been. So there was bad human decision making, there was socio-political effects, and there was human error. And had the eruption happened 3-4 days later, there would have been very few people killed. So the effects on the impacts can be quite different by tweaking just a few of these tiny little parameters. And if we do this in a systematic way, where we tweak many of these parameters thousands of times, we can build up a much bigger data set. And of course, that's an example where we have upward counterfactual thought, as we call it, which is where a past event can be better if we change some of the input parameters. But we can also have a downward counterfactual thought, or even a sideways counterfactual thought, which is where we change any of these parameters a little bit, and the consequences actually get worse in a downward counterfactual thought exercise, or maybe remain the same, but as a different sort of impact. And this is one approach that I think we can use systematically to improve our data set and to see how humans can influence the effect, can influence impacts, and how we can therefore use that in forecasting disaster risk going forward.
All right, thank you, Susanna. I'm gonna grab the screen from you again. Okay, so I think we've had 2 very interesting talks which cover very high level thinking about how to even approach these problems. One of the ways that we can move forward, I think, as a community is to encourage further discussion and idea sharing. So what we've done in this session is, instead of doing a Q&A where we try to answer specific questions, everybody can pose questions and everybody can answer each other's questions. And we're going to do this via an online forum called Padlet. Here is a link to it here. I've also posted it in the chat. A tiny URL will be easier to type in. And it's basically a virtual wall where you can post content and comment on other people's content. So the goal for the last part of the session is for people to interact using this forum. I'm going to, right now, move my screen over to the Padlet here. And I'm going to show how you can add something that you might want to talk about or present to other people. I had a study last year that was looking at the human influence on the Palu Valley landslides that were caused by irrigation practices. So I might want to put that out and have people comment on it. So what I'm gonna do is press the plus button, and then I'm going to basically paste in or type in a title with my name and where I'm from, and then maybe a short description of what I want to say. And then I'm gonna add a URL or a link to a news article that was about this, this event, like that. And you will be able to post comments to it and start a conversation. If, my lights just went out. If you have something to say, there's a section underneath every post where you can add a comment. So right here, we have posted Gillen Malamud 2017, which is the paper which is the basis for Bruce's talk. And I'm gonna add a comment that just says, thanks for this PDF of the paper. Okay. So what we would like you to do is start adding things to the Padlet. The panel is going to watch as the Padlet starts to be built, and we're going to respond to what you say. So if you have a question, you can type it into column 5 here using the plus button, and we can respond to that question. So let's see. We have a few comments, but thus far, I don't know if we have any new posts. Okay, somebody is writing in a question. Thank you. And please feel free to post almost anything. A field photograph of work that you've been doing, a question for the panel, A paper that you think is relevant or interesting can be posted. And this will continue through until next year's session. Okay. So here we have a question: how can I map or indicate anthropogenic influence to a landslide model? In the case of the study that I posted here, we looked at the spatial correlation between agricultural practices and liquefaction during the landslide. Okay, here we have, Bruce has posted something from Kenya about drainage networks getting clogged by plastic bags that enhance the risk of flooding. That's an unexpected human influence on a hazard, I would say. Okay, so while people are filling this in, I have a few questions for the panel to kind of reflect a little bit on what we're seeing and what we've learned. Pak Agung.
Yeah.
Indonesia is one of the most rapidly developing countries in the world.
Yes.
It's also one of the countries most exposed to a wide variety of natural hazards. In your experience, as you've gone through life paying attention to these things, do you think that human influence hazards are becoming more prominent in Indonesia over time?
Yes, sure. Especially near the Merapi volcano. I think Susana also did some studies there that the 2010 eruption. So most of the casualties is, let's say, it's the people who live near the the river or like that. And another effect is the modification of river flow. Yeah. So then when Merapi has eruption in 2006, so we call it a Kali Putih or Putih River. Yeah. So the people preferred the river, but because at that time there is no lahar flowing to the river. But after the eruption of Merapi 2010, yeah, so we have a big lahar flooding in the river. So it's let's see, cover many houses. So then some people should be evacuated like that. Yeah. So this is just let's say the example for the urbanization, or yeah, the growing of population. Yeah.
Urbanization, I think,
yeah,
has been identified as one of the primary human activities that affects many hazards.
Yes.
So, Bruce, do you have anything to say about what you're seeing on the Padlet?
Yeah, so one of the questions is, how can we use the knowledge of anthropogenic processes influencing natural hazards? And I think what's important here is that if we work with policymakers and hazard managers, we can start designing interventions that might reduce the impacts of this linkage. So I'll give an example from Nairobi in Kenya, where I'm doing some work. And this is that a lot of water right now is carried by the very poor people in small plastic bags. And what was happening is these plastic bags were then clogging the drainage networks. And so that when there was a flood, the drainage networks were not operating in the way that they should. So an intervention that was taken in Kenya was the policymakers recognized this, and so they then outlawed the use of plastic bags. Now, this has a whole set of other things, but the purpose of mapping these linkages systematically is so that we can be aware of where interventions might be taken, so that we can either reduce the impact of the natural hazard itself, or we can reduce the exposure or the vulnerability of the people thus reducing the overall interactions. So I'll hand back to our moderator now.
Thank you, Bruce. Susanna, I see a question that somebody has put in, which is, are there examples of participatory methods with communities or the public, citizen science, to support these approaches? Can you comment on this?
Yeah, so there's some interesting work that's been done a lot in the Philippines by a colleague of mine in France, so Jean-Christophe, and Gaillard, he's now in New Zealand, and he uses specifically 3D mapping. So the idea is that if we do all these very funky maps with GIS and we try and map everything, then when you go to a community that maybe doesn't have access to GIS or computers, then it's useless. So this is about trying to make sure you have community participation and understanding. So they build these 3D maps out of locally available materials, so papier-mâché, pins, paper clips, and they ask people to map their community and then how the hazard and the risk might change as a function of things that they can do within their community. So improved evacuation routes, dredging the river, whatever it might be. And I think that's a fascinating example of actually making sure that whatever we do in research is applicable and usable by the end users.
Great. Thank you. Bruce, I'm going to send this question back to you, I think. One of the things about the presentations that we had today is we're trying to make new ways of thinking about things, new structures, new even thought processes, downward counterfactual thinking to expand our set of events that have potentially happened, or matrices of different human influences that can affect each other. One of the questions is, lack of progress in science communication is a bigger issue in the developing countries. And this single factor is very important and for many things. How do we start to communicate these more high-level, big picture approaches to systematizing this science to the general public?
Yeah, so the way of communication, I mean, there's a lot of work that is being done on this. But one way is to think of it in terms of risk matrices, where you have impact and you have likelihood of occurring, or something like some combination. And this is commonly used right now with the public, that we take a variety of different natural hazards and technological hazards, and we put them all onto a graph, so that the public and also we start seeing what is the relative impact, what is the relative likelihood of events occurring. And so it's basically trying to put different anthropogenic processes and different anthropogenic process natural hazard links into a common viewing, so that people can then say, oh, earthquake, flood, and what is my impact on those? So it's some relative weighting of these that's then communicated in a language that people can understand in the public, so that they don't think that driving a car is a lot less dangerous than, say, something like a terrorist attack, when in fact it's much more dangerous. So it comes down to risk perception.
Okay, thanks for that, Bruce. I have a comment here on Dr. Balaram Mohapatra's comment from India, which is about subsurface drilling. And one of the things I think is really interesting when we put our natural hazards word cloud together is the emerging issues in human influence hazards, the hazards that have not yet been, or the activities that have not yet been identified as really important for the future. How do we identify these things before they become such a big problem? Because we all know that climate change now is a big problem, but at one time it wasn't identified very well as a human influenced activity. How do we go about making sure we add new data points or new activities to the matrix? I can just send this one to the overall panel maybe.
I was responding to a question, Carl. Can you summarize the last little bit?
Yeah, I was also responding to a question on the
Human
Padlet.
audience interaction. How do we add new human activities to the matrix? How do we determine what is going to be influential in the future without having to have a big disaster to tell us that it's going to be a problem? So one of the questions was talking about subsurface seafloor drilling. I think seafloor mining is another one of these emerging issues maybe. How do we go about adding to the list?
So I would say numerical modeling is one way where we can forecast using models of what we think might be the case. And when we don't have a past event catalog to draw on, we have to use that, and expert judgment. I think in some cases you can use analog events. So if there's something that's similar, you could sort of draw inference from that. But without an event set, we have to rely on expert judgment, analogs, and modeling, I think.
And if I could also reflect on that, which is the idea of systematically looking at natural hazards or anthropogenic processes is to look at the literature, to look at the case studies. And by doing that, what you're doing is you're taking yourself out of your individual region or your individual specialty to be aware of case studies that have occurred elsewhere. And I think a lot of what we think of as unexpected has actually occurred elsewhere. Now, the second one is actually a bit of an odd one, is you get a bunch of people in a room, the expert judgment, and you say, what might occur? What haven't we thought of? And what might be a little bit odd is sometimes you invite people like science fiction writers to these, because these are people who are creatively thinking about what might occur that we haven't thought about. And so it's systematically thinking about what has occurred, what might occur, and what in our wildest dreams might occur.
And actually, that's where the framework that I presented is quite useful, because sometimes that sort of wide-ranging thinking is difficult for a scientist, exactly like you say, Bruce. So we invite people from outside of the sphere to contribute. But if we break it down into little, like, bite-sized chunks, like what if we change just this parameter or this parameter, then it's a little bit easier somehow for scientists. I imagine if you're a science fiction writer, it's already something you can do. But that's one approach that can be useful for that sort of thing.
Okay. Thank you. We're rapidly approaching the end of the session. I want to thank everybody who contributed to the Padlet during the live discussion. It was a big experiment, I think, to try to see how that would go. Please continue to use it to make connections and answer questions. I will revisit it over time. Let me go back to my slides. So the final thing I want to say before we have to leave is that it's not over. Please join us tomorrow for 2 more sessions. One is going to be natural hazards in the megacity. There's going to be a lot of similar links between what we were talking about today and tomorrow. And then theme 4 is going to be remote observation and monitoring for natural hazard forecasting and response. I'd like to thank the organizers of the conference, the virtual conference. I'd like to thank my fellow panelists and conveners of this session. And especially I'd like to thank the audience for all of the contributions you gave during this talk. And I hope that we'll be able to do this in person next year in the future. And with that, we have 1 minute. Does anybody have anything else to say? This is a really burning thing.
Just thanks to you, Carl, for this. This is a really interesting way of holding a virtual conference. So thanks to you and everyone else for putting this together.
Okay. Well, it's hard to know how to end. I don't want to go. Bruce, do you have any last word?
No, just on behalf of the steering committee, thanks everyone for attending today. And we really do look forward to seeing you tomorrow. 300 attendees today. That was great. More than 300 attendees. And we'll see what happens tomorrow for these 2 sessions.
Okay. All right, I'm going to stop sharing my screen now. Thanks to everybody.
Bye-bye.
Bye.
Bye.